Alrighty, it is Monday morning. Welcome to a fairly casual office hours session. Let me just check if everything is running. Seems to be. Alright, good. Now, this is specifically aimed at my in-person classes, so to speak. So we will start by discussing the content of an upcoming final exam, and I just wanted to go over the problems that we should be focusing on. So first, let us just see where our voting has ended. So let me just open Krita here. So we have something to write on. All right, this will be our math 143 final exam topics. So we voted, and from each of the quizzes, 3 pages were selected. It will be page, I'll call them A, B, and C, I suppose. A, B, and E, so 1, 2, and 5, and we'll discuss what those are in a second. Page or quiz number 2, the topics coming from that will be B, C, and E. So pages, I suppose here, B, C, and E. And then quiz 3, the highest voted topics were, ooh, that was a little tight, ABC. Pages A, B, C. And lastly, our most recent quiz, quiz 4. The votes are in and they were very tight. A, C, and E. Pages A, C, and E. Now, if you want to know exactly what those topics are, they are listed in the course-specific channel on Discord. Let us just have a look at appropriate problems. So let's have a look here. So how should we do this? I'll just do it alongside. I think that is perfectly fine. So here we'll have maybe some separator lines. So we know what we are talking about. So this is the problems, suggested problems we can look at to prepare for each of those topics. So let me go to our first one, which is basic sequences. Basic sequences, I guess over here. Oh, there we go. So for that, we want to look at problems 1.4 and 1.5. 1.1 is a good introduction, which we've done now, so I'm not going to include that for our test. What is this line doing here? Get away from me. So problem 1.4, 1.5 will be sufficient. Now B was really just the definition of the arithmetic sequence. So for that, we're going to go and really just understand this page. So that's page 17, the formulas and so on. So I'll just call it page 17. And E, all things Fibonacci. Let's jump down to the Fibonacci sequence. So that starts on page, what is this page? 25. How the sequence came about, the formulas, can I use the formulas, patterns in the Fibonacci sequence, Fibonacci squares, the spiral that comes from those, where does the Fibonacci sequence occur in nature, what's the golden ratio, it's linked to the golden ratio in art, and a formula using the golden ratio. So page 25 to 31. Page 25 to 31. So problem or page suggestions. There aren't problems for those when they're just facts in a discussion. Alrighty. Then we move on to the topics coming from quiz 2. First one up is a B. Our Venn diagram questions. Let me just list all those like that. B. Let's go to the Venn diagram questions in terms of the problems. So I want to be prepared for problem 5.1. Oh, stupid line. So this will be the problem 5.1. And then we have some word problems, not those, starting at problem 5.4 all the way to 5.9, 5.4 to 5.9, 5.4 to 5.9. C was conditional probability word problems. Is that correct? Sure. C, conditional probability word problems. Where are you? Now, I don't want to forget the exercises. Even though I'm listing problems, it doesn't mean the exercises always came first. So an exercise like 6.2, I don't want to forget. But regardless, problems it is. Some are nicer than others, for sure. The wording in 6.1 is a little more difficult, but it's a nice question still. 6.1, 6.3, 6.4, 6.5. So 6.1, 3 to 5. Problem 6.1, 6.3 to 6.5. All right. And then we have weighted average, mean, median, mode. Weighted average, mean, median, mode. Where are you? Measures of center, yes. Looking for the problems here. Honestly, I think all of these. Yeah. Well, no, not all of them. No, not the random variable expected value, right? That is in probability distribution. So let's make it up to 811. 8.1 to 811. Problem 8.1 to 811. All right. Okay, let me just double check something here. So that puts us halfway in the final exam. Next up is the quiz 3 topics, A, B, and C. So let's go and have a look for A, B, and C. What problems are the most appropriate? It doesn't mean if you just do those problems and absolutely nothing else, then it's going to be perfect. You still have to understand the topics, of course. First up, Polygon terminology. Oh, that's easy in terms of the problems. You just have to know them all. Problems 9.1, 9.2, 9.3. Problem 9.1 to 9.3. B is where you need to get a compass and a straight edge and construct some stuff. Compass straight edge constructions, Euclidean constructions, call it whatever you want. Let's go to the problems here. Where are the problems? Come to me. We're not going to deviate from what we did in the quiz. I am not going to worry about inscribing a circle in a polygon, but definitely problem 10.1, circumscribing. Let's just write that down. So given a shape, problem 10.1, given a polygon that works like a triangle, can you put a circle around it using only your compass and a straight edge so that it touches every vertex? And that method is described there. I don't necessarily want to do these problems. It's more the exercises that we have done. So what have we done for the exercises? I'm looking. So here, given a circle, can I inscribe in the circle? Can I put inside the circle an equilateral triangle, regular hexagon, square, regular octagon, and a regular pentagon so that the vertices all sit on the circle? So I'm going to call it exercise 10.1. Exercise 10.1. And where is the pentagon one? Pentagon we did separately because it is a little bit more involved. 10.2. So those aren't listed as problems because it is the exact same question. You just practice it over and over and over. Exercise 10.1, 10.2. Next up, page C, unit conversion. That is the very next chapter. Measurement and unit conversion. Now it could be length unit or area unit conversion. Let's just see the problems there. Now in our problems, we are going to have to include some area conversion as well, since Those were missing in this draft of the book. So let us start by saying problem 11.1 and 2. Problem 11.1, 11.2, but we're going to have to go up to the exercises for area unit conversion. So exercises 11.4, 5, and 6. Exercises 11.4, 11.5, 11.6. What is 11.3 and 4? I don't even see an 11.4. Okay. So those are going to cover everything, yeah, for that portion. Then our more familiar, because it was recent, quiz number 4, a C and E. C just edged out are voting with one vote. It beat out B. So A, C, and E. So first up is trigonometry. Whoops. A. So let's go to that. It'll be the same as the quiz. Where is our trigonometry here? Come on, trigonometry. I know you're here somewhere. There you are. In that we want to be able to convert between radians and degrees. Radians and degrees. So that'll be 15.1 and 15.2. So problem 15.1, 15.2. And for the word problems, I'm not going to specifically list the individual trig function questions, but you won't be able to necessarily do the word problems without looking at these other problems. But I will leave that to you to realize the obvious. For the word problems, 15.6, 7, 9, 10, 11. 15.6, 7, 9, 10, 11. And then C is platonic solids. There aren't any problems. Let me double check when it comes to the platonic solids. Maybe there are, but the problems here in chapter 16 are more guides of the kind of questions. So 16.1 covers some things I need to do for the platonic solids. A 2D representation does not mean a net. It is a two-dimensional drawing of the three-dimensional shape. If I wanted a net, I will ask for the net, which I won't. Many people did that in the quiz, which I gave it to them, but that's not what we're looking for. 2D representation of each platonic solid and its name. Sure, that's something you have to do, but you also have to know the faces, vertices, edges, and vertex figure name. And I don't see those questions here because they are coming from the book. So I would rather, for the platonic solids, say, let's just go up to the page here where they are all listed. Come on, page faster. Whoop, I've angered it. If I look, for example, at the icosahedron, it says the faces that come together are triangles and 5 of them, 20 faces, 3 points for total contribution. Then that gives me 12 vertices. It has 30 edges coming from Euler's formula. So maybe these pages will be a better idea. Example 16.1, 2, 3, 4, and 5 might be better. Oh, they're summarized here. Well, there we go. Let's just say pages 11, 16, and 17. Pages 11. No. What did I just say? 116, 117. And don't forget vertex figure names, which are discussed. We need Euler's formula, of course. It's optional, I suppose. But in the quiz, you do have to show your work. So if I ask for the number of edges and you just say 28, well, it says on the front cover of the test, you have to show your work because anyone can just go look up the answer. How do you get there? It's an open book test, so you have to show more than just the answer. Vertex figure name. I'll just write it down here. And vertex figure name as well, even though that is discussed on a later page. E. E is area and volume calculations. Oh, no semi-regular polyhedra. That's a shame. Area and volume calculations. Let us go to that chapter and find some problems. Ooh, I like it. Where are you, problems? Okay, so there's going to be a lot. We're not doing scale factor, though. Ooh, maybe we should include it. I'm going to include it. I am. So problem 17.3 all the way to the end of the chapter. There's a lot of overlap between these questions. Yeah, 17.3. You voted for it, so you like it. 17.3 to the end, which is 1720. And there we go. Happy times. Let me just check since I've been talking. If anything has happened, nothing at all. You can let me know if you have any questions regarding this, but we will of course have office hours tomorrow and so on as well. So if there aren't any questions, I don't want to switch topics and talk about much else now. This was just a quick session to confirm the final exam for this specific course. And I'm sure tomorrow we'll do some actual problems. All right, I will stop here and leave it until tomorrow.